Hello everyone. Today I thought I would be doing something different from what I've always used to do on this channel. And what I thought of doing is maybe I wanted to show how I develop some OpenGL stuff from scratch, completely from scratch, using C++ and CMake as my module and project generator. And in the meantime, I have some loyalty-free music playing on Spotify. I don't know how well that will work out in the end, because I heard Twitch is not very friendly with music playing in the background. But hopefully it won't cause any problems. So it's just me basically rambling about how to develop some graphics using C++, and I'm always getting stuck at one point because I just don't know how to go further from that. But I guess I just need to watch more tutorials. So in this video, in this stream, I just really want to show how to get the resources you need in order to create a context where you can draw OpenGL stuff, and what drawing OpenGL actually means. So I have a 4K monitor, and on one of the quarters in the top right corner I have my Visual Studio open, which I will be using for this stream basically. And hopefully the quality is okay for the display. I stream 180p and both input and output, so it shouldn't really have any problems. Let me actually go to my channel and see if everything is right. It looks like everything is okay, so I'm actually satisfied with this. So yeah, actually let me open up a paint where I will be drawing some stuff. It's a very professional way of creating diagrams and such. So here's what we need to do. We need to create a window where we can have some 3D objects drawn as such. You would be seeing my amazing art. To like, oh, for fuck's sake. You would have some sort of cube drawn like this, or something of the sorts. Paint is not very comfortable to draw with, but you get the idea. So we need a window, and what I will be referring to as a context, and the context will be able to get some information, some vectors and triangles as information, and some perspective, like projections of what to display on the context itself. So we are going to use two libraries, one for window creation and context creation and input-output handling, and the other one for communicating with the graphics card itself. So to call methods and data structures and set the entire OpenGL-like state machine. I will be explaining what it actually means, but let me actually just start it. So I'm going to go ahead and create a project and solution in OpenGL, and not open, but create a whole new project. And I will just name this, I don't know, what should I name it? Stream engine, which is a really bad name. I should not call it that. Naming is such a hard choice. Okay, how about Palm engine. I'm just gonna call it Palm engine. And in Visual Studio, if you have, I don't know, 17 community edition or 19 community edition, that's perfectly fine. You can also download or this extension where you can create cross-platform projects, and we are going to use CMake in order to have this platform independent project built up for us. So I'm making a CMake project called Palm Engine, sorry, and I'm also creating a Git repository. If you don't know Git, I won't really go ahead and explain what it is. I assume you kind of have the knowledge of what it means. It's not complicated. It just manages your sources and with commits and stages and such. So you could have like incremental versions of your software as you develop it. So I'm just gonna go ahead and click OK, and we'll see on the left side that we have our project created, our module, Palm Engine module created for us, as well as a CMake lists file for both the module and the entire project. We can actually take a look at what this actually means. I don't know how well you are able to see this. This looks pretty small on my monitor, but I think it would look, well, it looks a bit nicer on the stream. So what's down here is not the output console is not really important for us right now, so I'm not gonna go ahead and explain what that does, but I will try to increase maybe the font just a little bit so it's easier to see for everyone. Okay, so what the CMake list is basically tells the entire project how it should be built, what modules there are, what things you can include, and what steps the modules should be built, so your project is built in a perfectly optimized way, so to say. So what we see here is that we are going to use at least 3.8 of CMake to build this project. I'm calling it Palm Engine. This entire project, which will be built, is going to be called Palm Engine, and we are adding a subdirectory called Palm Engine. Now the subdirectory is referring to this folder right here, which also has a CMake lists.txt. That is very important because adding a subdirectory means that you have a folder with a CMake lists.txt inside of it. Otherwise, this whole thing wouldn't work, and CMake would complain and throw an error. So inside the Palm engine, we see that we are still using at least 3.8 to run CMake for it. What we are doing here is we are creating an executable, like an exe that you can run on your computer called Palm engine, and for that we are going to compile Palm engine.cpp and Palm engine.h, which can be seen right here. Now this header file doesn't really matter whether you have it or not. It basically just has one include for the example code that you are given. And I don't really like that, so let me actually get rid of this header file because it's completely unnecessary. It's gonna ask me if I want to delete this permanently. I say yes, and of course this include wouldn't work anymore. And on the top it says we have this CPP defines the entry point of the application, and this is where we will be running our application from. So going back to the CMake list, now that I have deleted the header file, I wouldn't need that anymore. So my project will only rely on this one CPP file. And if I go ahead and, I don't know, for example, let me try to include IOStream, which was included previously with the header, but I deleted it because it just confuses people anyway. So for the standard output, I'm gonna say, well, just everyone says, well, I'm gonna write what everyone does at this point. Hello, Palm engine. And I'm just gonna put an end line to it. And let me make sure that this compiles. You can right click. If you are using Visual Studio, you can right click on your CMake list file and just go to build, and that will build your project. And at the bottom it says build succeeded, and that's really good. And at the same time, our main CMake list also kind of shows that we only have one module, which is Palm engine, which is perfectly fine at the moment. And if I go ahead and select Palm engine.txt exe and run that, I of course get a extremely flashy screen because the console has outputted hello Palm engine to me, and it immediately closed. So just to show you that it actually does work, I'm gonna call the console in.get, which kind of assumes that it will receive some input from the keyboard. So let's run that again, and right here we can see this is way too big. This console is way too big, but anyways, we can see that it says hello Palm engine. As soon as I hit enter, it will disappear and close the application. So that's all fine. We know that C++ works on this computer, and we really want that to work. So, and here comes the kind of more complicated part. I open up Paint once again and show you what I mean. So at the very top we have the main project descriptor descriptor, which is our outermost CMake.txt, CMake list.txt, and inside that we would have Palm engine, which is a module. And besides this, so how should I kind of display this? Our main project is kind of building Palm engine, but we need, okay, let me actually use the brush. We need a few dependencies for the Palm engine to be able to build, and how I will depict it is just gonna draw arrows here to show that we need two dependencies, two libraries that we will be working on. The first one is called GLFW, which is responsible for creating a window context, and it really handles input really well. There are other libraries as such, for example SDL2, which are adequate as well, but it can also handle sound, for example, 3D sound, but I'm not familiar with that, so I'm just not gonna use that. And some people prefer other libraries because GLFW is a bit old, and there are a lot of stuff that looks like legacy code. But this is more than enough for our needs right now. GLFW is really enough. And the other is GLEW. And GLEW is just a set of libraries you can use to communicate with your graphics card and call graphics card commands, basically, and execute some pretty good things on there. So what I will be doing so we need these two modules, GLFW and GLEW. So I will be downloading them via GitHub. You can do something like this. You can open up your terminal or your full directory where your project, the root of your project is, the project root. And I'm going to open up this git bash where I can basically type in stuff like git sub module add, and after add I'm just gonna go ahead and look online GitHub GLFW, and of course there is a package for it, and just gonna go ahead and paste this URL. And what it's gonna do is it's gonna create a subfolder called GLFW. I can also specify this by typing another argument after the URL, but I don't really need it. It's just gonna take this as the folder name, the last thing after the slash in the URL as the folder name if you don't specify anything. But anyways, what this is gonna do is it's gonna add a directory called GLFW and download everything in there. But when I upload my project on GitHub, it will not contain anything except from a link to the GLFW GitHub. So let's go ahead and run that, and it's downloading the stuff for me. And if I look back, I have the GLFW folder. Again, if I go back to Visual Studio, I have the GLFW folder downloaded for me, and that's really good. Before I move on, I want to download GLEW as well at the same time. So I'm just gonna go ahead and say git submodule add, and I'm gonna look up GLEW GitHub, and there is a GitHub for GLEW, the official one, but I really need to have it with a CMake. So there is another like sort of semi-official library by Perlmint, who created this, like cloned the entire GLEW library and created it in CMake. And for this one, I don't want the folder to be named GLEW CMake, so I'm specifying what the folder should be after downloaded. So I'm just gonna press enter. It's cloning, and I can just at this point close this window because I can see that I have both GLEW and GLFW on my computer. Now, going back to this this little picture, I need CMake to build GLFW and the GLEW before it builds Palm Engine. So let me actually go ahead and specify that right now. So here I'm gonna say add subdirectory GLFW. It doesn't really matter whether you put it in quotes or not. Everything is a string in CMake, so this is completely fine. And of course I'm gonna add GLEW as well. And hopefully this will be enough. Well, it's not really enough. I know that it's not enough, but it's enough for Visual Studio to recognize that there are new libraries present in my build command. So let me actually check something which I haven't checked before. So if I have, yeah, okay, that's subdirectory GLEW. Okay, so I was just checking whether GLFW would actually try to compile GLEW as well, but no, it wouldn't. So check if this actually works. I don't think it would work. Yeah, there's no such thing as GLEW static, so it's for the linking later on. So now we said to CMake that okay, these are the modules that you need to build. And in my project, when I'm writing my code, for example, the window class, I would like to include something like GLFW, GLFW.h or something. Now, my system doesn't recognize this because I haven't told CMake what it actually is or where to look for these kind of stuff. So from both GLEW and GLFW have this include folder, and I'm gonna tell CMake to look for these and add it to my modules that I'm building. So I'm gonna say target include directories, and I'm gonna say Palm Engine public, and after public, I can just go ahead and specify CMake current source dir, which stands for directory. Go ahead and say glfw /include. This will point CMake current source dir as the directory of this current file, which resides here, and this directory has a GLFW directory inside it, and inside it there's an include. So I'm just gonna go ahead and copy this. No, I'm just gonna type it out again. Target include directories. Nah. Palm. I want to include these directories in my Palm engine as a public resources. CMake current source directory /glue /include. And with this, what just happened right now is I can go back to my Palm engine CMake lists and no, sorry, I can just go ahead and in Palm engine say include, and see these two folders appeared because of these two lines. I'm pretty sure this would work all the time unless your folders are in a different path. But as for now, as we can see that I can include both GL glue and GLFW3. So I said that we need GLFW and glue to build in this order, but if I try to compile this, then I get an error saying that glue needs to be included before GLFW3. This is like very specific, error message that you get. I don't know why that is. I haven't really looked up, but I'm pretty sure there's a reasonable explanation for this. So I'm just gonna go ahead and include glue right before GLFW3, and we are still not there yet because if I were to create something like a GLFW window GLFW create window with a width of 300 and a height of 300 and a title of hello or something, and give some null pointers to the rest of the arguments, because I'm not sharing a screen and I don't have a parent process, so these two can be null pointers. And I can see that like Visual Studio recognizes this as a type, and that's perfectly fine. It kind of has like a trouble finding this as a function, but if I look up, if I press Control and click, it takes me right to the definition inside the right file. So you can see it finds it, but the problem with this is it's not linked. So I can try to build these. First, I'm gonna go and, just for the sake of it, show you how things should be built. So first, I build the glue libraries, and then I build my GLFW. And after all those are succeeded, I can go ahead and build my Palm engine. And that said, it's failed because if I go ahead and enlarge it, it will say that I have unresolved external symbols, and especially with this GLFW create window, it's referenced but it cannot find the definition. So another thing we need to do in our Palm engine CMake list is to link the libraries we want to use with the Palm engine. So I can go ahead and say target link libraries. I want to connect to the Palm engine, and I want two libraries to be linked to my project, which are GLFW, it's pretty easy. And the other one is glue, which we have specified in this CMake list as glue and GLFW. The problem with this is, even though this is found, this wouldn't work. And I don't know how, like, I looked up the CMake file of inside glue. I went over it and I don't know why. I just wasn't able to link it with my library unless I used unless I tried to link this one, libglue static. So I don't know what causes that, but the way I managed to make this work is that I used libglue static, and with these parameters, I had my Palm engine connected to both GLFW and glue, and with that, we are pretty good and set to go. If I were to compile my Palm engine, it would say build succeeded because it had found the right libraries. So this works pretty well. Let me actually go ahead and be a social whore for a second and go on twitch.tv and share my stuff on Facebook because I like to do that. So of course this is just a very beginner level of how to create a project, an OpenGL project that uses GLFW and glue libraries and the CMake as a project generator. So what I'm gonna do right now is to actually give the input of how to, well, specify or specify to the hardware what I would like to initialize. First, what you need to initialize is glue, obviously, because we need to create the window. So I'm gonna say GLFW init, which initializes the context that is needed for creating windows and such. It just sets some global variables and I don't know whatnot. I haven't really looked into it. I just know this is how it's done. And this will return a a true or false something, and if it fails, we should quit the application. So I'm just gonna go ahead and say static bool init initialize GLFW, and this will return GLFW init. And if this fails, if initialize GLFW fails, then I'm just gonna go ahead and return I'm just gonna go ahead and say what should I say? Well, actually, you know what? I'm not gonna go on bother. I'm gonna refactor this code later on anyway, so let's not overcomplicate things. I'm gonna go ahead and say if GLFW init. Sorry, if that doesn't happen, then I'm just gonna go ahead and put some on the standard error line that GLFW initialization failed. Gonna end that line, and I'm just gonna quit the application with a -1 for now. Now, at this point, GLFW initialization runs, and if that doesn't fail, my program is gonna just go ahead and run run the lines after it. So let's see what we can do with this. Before I create a window, let me actually try to create, oh, I can only create one of this at the same time. Anyways, we don't really need this diagram anymore. So I'm just gonna go ahead and not save that. So before we create a window, we need to tell, okay, what sort of window is this? What is the context and such. So what versions are we using? So we need to answer these questions before we actually create an entire window, right? It's kind of like me asking you to translate a certain text, and the first question of you, okay, what language should I translate from? Well, you get the idea. It's not quite like that, but it's very similar to what preconditions it needs to consider before creating a window. So I'm just gonna go ahead and say GLFW window hint, and this function always takes two parameters. The first one is well, I can give this in any order I want, but I will be doing this GLFW OpenGL GLFW context version major is gonna be 3, which is OpenGL 3 dot, and GLFW window hint GLFW context version minor, which is also 3. So we are using OpenGL 3.3. The reason for this is that OpenGL 3 is what is considered to be the modern OpenGL, where you can write your own shaders, and but 3.0 still had 3.0, 3.1, and 3.2 versions still had this immediate mode for OpenGL, which is complete bullshit. So the first version that excluded completely or got rid of the immediate mode, the old really bad way of creating context and drawing stuff on the screen, has been abandoned in or has been completely gotten rid of in 3.3. So this is why we are using 3.3, and this is why that is considered to be the modern OpenGL version. And I'm just gonna go ahead and create 2 more of these settings. GLFW. So we have set the context, and I'm just gonna go ahead and say OpenGL profile. We are gonna say that this is an OpenGL core profile, and just gonna go ahead and say another window hint, which will say that GLFW OpenGL forward compatibility should be GL true or something. Well, this GL true, I'm pretty sure is the same as GLFW true, because both of these libraries defined this. See, GL true is 1. If I go back and say GLFW true, hopefully it will find it. And yeah, this is also defined as 1, so it doesn't really matter which one you use. You can use GLFW true to be consistent with these parameters, or you can use GL true. It's the same thing. It will be literally the same thing during compile time. So now that we have this set up, I can create my OpenGL window or my GLFW window, which will have the context. So we are going to use the pointer and the raw pointer currently, because GLFW can manage raw pointers when it kind of like before the program closes, it can clear up everything for us, so we don't need to really worry about resource management at this point. I also tried a lot of times to create not this a raw pointer, but to use the std unique pointers. pointer and GLFW window. Unfortunately, I just didn't quite understand why it wouldn't work, so I'm just sticking to the raw pointer for now. Maybe in a later stream I will use or figure out how to use the raw pointer for this special type. But for now, I'm just gonna go ahead and create the GLFW window pointer, and which I'm gonna simply call window. And with that, I'm gonna go ahead and say GLFW create window, and I'm gonna specify the width. You can create macros and create like signed chars or ints or whatever you want. But I'm just gonna hard code it inside this. So I'm gonna go ahead and create a is this gonna be what? No, it's fine. A 1280 by 720 pixels screen with a title of Palm Engine, and with the GLFW monitor, I'm using my primary monitor to display this. So I can just specify a null pointer here, and I mentioned it some minutes ago that I don't really have a parent process or like a process that will be sharing this, so I don't need anything else as well. Those two parameters, so these can stay null pointers. First one is the specifying which screen you want. If it's a null pointer, it's going to use your primary. The second one, I believe it's when you have like several, when you have like a main process that uses GLFW window, you can like attach it to that window or something, but this is obviously not the case here because we are the first running window in this application. So this is why I specified this null pointer here. So here, just to be consistent with the GLFW initialization, we can also check whether this is a this window is a null pointer. And if it is, then unfortunately we need to say std error that GLFW window creation. If I could type, that would be great. Failed. So go ahead and end line there, and we can basically say GLFW terminate because we need, well, we know by this point that we could initialize GLFW, then at this point we can terminate it as well. But just to double terminate it, I'm gonna quit the application with -2 if we reach this point. So hopefully we won't ever run into these. Creating a pointer fails when there is literally not enough memory in your system. And I'm using an x64 build, which means that it would be nearly impossible for this to ever happen. Because the operating system would always find us a way to store this pointer somewhere, or allocate somewhere on the heap, or find heap for this object to be allocated on. So anyways, let's go ahead and continue further. Now that we have our window, it's basically ready for display. Well, not quite, but almost ready for display. We are lacking right now the communication with the graphics card to, hey, graphics card, do this and do that. So this is not something explicit. This is not something that is explicit in saying that, okay, I'm calling my video card something, and card, and pushing some information on there, but the functions that I will be calling do communicate or do send the final the information to my video card. So so we have the window. What we need to do is to create or to make this the current context. which means that we are gonna be drawing on this window at this moment, and I won't be changing this. So this don't need to be applied in the render in the render cycle. And I think this is basically it for GLFW. I don't think we need any more tweaking as for this very early parts. But we can go ahead and say GL experimental. Glue experimental equals GL true. Which means that I actually don't know what this means. So don't ever quote me on this. I just know that this should be turned on when you are using... Actually, I don't know what. I'm just gonna not tell you what it does because I don't know what it does. And after this we can initialize glue. Glue init. Now this doesn't really it doesn't really give you like a boolean or true or false. It will just give you a status code. And if the glue init is not equals to glue OK, which means that everything worked fine, then again we should output some error code on the screen saying, okay, glue initialization failed, and end line. And at this point we can destroy the window. Destroy window, no, because we have created by this point we have created our window, and we can terminate GLFW and return, for example, -3. Of course, these values can be defined somewhere else if you really want to. For now, I just don't really feel like doing any of those error codes or try catches and all that stuff. Just writing pure kind of C++ borderline C-ish here. So anyways, what we can do now is specify a color for what the background of our window application should be. So going back to my paint example, if I have my window here, it's gonna be just pure white at the back because I haven't specified anything. But I can, like, for example, say that there's this bluish color, or I don't know, like red color or something that should be painted before anything happens. So so how that's handled is that GL clear color. GL clear color is a function that takes 4 parameters between, and each of these parameters has the value of 0.0 and 1.0 included intervals. So these are the red, green, and blue components, as well as an alpha component for the 4th parameter. And the color I really like is 0.3f, 0.3f, and 0.4f, and 1.0f. 1.0 is the alpha value, meaning that it's not transparent at all. It's completely solid colored. If this would be something like 0.4, then it would be kind of translucent. If it would be 0.0, then it's completely transparent. 1.0 is a completely solid color, so it's a full color, which is defined by these values, these first 3 values. So now that we have specified, we can actually go ahead and write something that is the render cycle, the rendering loop of our application. And this is going to be just a while loop. And there's like a really good... The reason why I really like to use GLFW is because the input handling, or how it manages your resources and based on the input. So while the window, GLF window doesn't close, so not GLF window, should close window, and that's it. This means until this window is not closed, then do the following things. So the first thing you want to do is to ask for the events from GLFW. These are the input, basic mouse and keyboard inputs, as well as many other inputs of your computer. And after that, we can basically GL clear color is done. Yeah, we can say GL clear. And we are going to clear GL color buffer bit. So in every one of these cycles, okay, let me just write one more command, which is GLFW swap buffers of our window. So these 3 lines are needed. The first one is every time we render a frame and we jump back to the very beginning, we want to ask what the user is pressing or what the mouse movements are. This is obvious because this is how we can sense, or like not sense, but this is how we can realize or recognize that the window is being closed. For example, the push of a button. So this is pretty self-explanatory. The second one is not so much. Every time we finish or we iterate through a cycle in the loop, we do this rendering called, well, not called, but like, for example, if I have like a red color in the background and I have some other colors, like a rectangular shape drawn onto it, and let's say this is it, but then I move the camera, then this entire thing would be moved somewhere here, for example. If I move the camera left or right, then the objects go to the right or the left. So that's pretty good. So, but if I don't clear anything that was on the previous frame, then what you would be ended up with is you would have this still displayed here, and on top of that you would have like your new position as well as the old one. So this is why we need to call this clear, and this will clear the color for now. Of course you can still, or you can also concatenate kind of with this pipeline. Of course this means bitwise OR in C++, so you can like kind of add this condition, the color buffer bit, with a depth buffer bit, which would also consider your how deep your 3D space is inside your in your scene, which is related to this diagram here. Okay, so and the last one is basically swapping buffers of our window. If I create another diagram, what really happens in GLFW is that you have 2 simultaneous buffers for your window. While the first one is being rendered, the second one is getting ready to be rendered. And if if one is done, you can go ahead and put it on the screen, and then when the other is one, you can put that on the screen. And while, for example, let's call this 1 and let's call the other one 2. So while number 1 is done, you can write to number 2, and when number 2 is done, you can put it on the screen and write to number 1. And this is what swapping is. So it's kind of like it ensures that your image is not fragmented, not torn apart. So as for some last touches, I'm just gonna go ahead and say GLFW terminate, nope, destroy window first. It doesn't really matter, but I like to do things properly, so I'm just gonna go ahead and destroy my window and GLFW terminate, and this should be it. I'm not sure if I forgot something. I feel like I did. Let's go ahead and see if this builds. it says build succeeded, so let's go ahead and run this application. And of course my console output is way too big, but as you can see, nothing appeared on the console, and this is the window that is being created for me. So where the colors come from is right here. This is the clear color. If I close this application and change one of these values to 0.9 and build that once again and start it once again, then you will realize that this is now the new background color. So again, yeah, these are the ones that specify the color and whatnot. Okay, so this is kind of the basic bare bones of how to create a GLFW context window, and we have reached a stage where we can actually go ahead and do some pretty serious OpenGL calls. But before that, I want to like make this code a bit more pretty or like compact. So I'm just gonna go ahead and factor out or like refactor some code so it's not very noisy. So the first thing is that I'm just gonna go ahead and set window hints, which is gonna be containing this piece of code right here. So GLFW or like GLEW or OpenGL is basically a state machine, which means that once you have specified these will not change until you change them again. So you don't really have to worry about this function not having the scope of this entire main function or whatever. So once these are set, these are going to be stay at those settings until you change it somewhere else. And so here I'm just going to go ahead and call this function set window hints. That can stay there. I don't think I can really factor out anything else, but I saved some space, I guess. So this is creating a window and checking whether that's fine or not. Of course I could do it with these as well, but this wouldn't really save me much space. It would be more modular, but it wouldn't save me space. So I'm just gonna go ahead and stick with these. Or yeah, no, I'm not gonna factor those out. So next we want to do is I want to show you how GLFW handles keyboards. So once again, I'm gonna go ahead and build and run my application. It still has that pink color, but now if I press escape or any other buttons, it doesn't really like do anything. So I'm going to show you how you can make or how you can listen to user inputs based on GLFW's window or like key handling capabilities. So right after you create your window and made your context current, you can say something like GLFW set key callback. And what this expects is for you to have a window, which we already have. And for the second argument, we need a callback function. And the way that works is you need some sort of function here that has a certain set of parameters and types of parameters. So this will be a void function, which is handle, you can name it anything you want, really. Handle key input, for example. And this is going to take 5 parameters. The first one is your GLFW window pointer, which is the window. The second one is an integer. Sorry. The last 4 actually are integers, are called keys. I think the second one is the status. The third one is the action, and the fourth one is the mods, like shift or control, whether you're pressing those buttons or not. And we're gonna check that if the key you pressed is equal to GLFW key escape, and the action that you are using is GLFW press. So this means when you're pressing escape, then we are gonna set GLFW set window should close window to, well, basically GLFW true. Or you can just, you know, put true in there. Both works. I assure you both works. Both mean the same thing. And well, else, you don't really need an else, but I want to show you how you can actually like see what you're pressing on the keyboard. So else, I'm just gonna go ahead and output the key. So say key is this, and the status is status, and the action is action, and the mods are the mods. Okay, and I'm gonna put an end line to that because it's gonna get hectic, pretty hectic. Okay, so now we have something like if you press the escape button, then we should close or set the closing status of our window to true, which means that when we pull our events and it realizes that we have pressed escape, then the next time it won't run and it will just quit the application. So let me go ahead and build this once again. And it says build failed. It's because I forgot to put the callback to the set key callback, right? So I have written this handle key input method or function, sorry, and I want to pass this handle key input function to this set key callback. So it's just me giving the name there. So you are not giving any parentheses, it's just the name. That's how it's a callback. So let's go ahead and build this once again. Now that the build is succeeded, and if I run it, let's go ahead and watch what happens if I kind of put it in a much better place. So like here's my window, here's my pink window, and if I press A, B, C or something, sorry, if my window is active and I'm pressing A, B and such, or like A, S, D, F, then you can see that the key I pressed for A was 65 and the status was 30. I don't know what that means. Action was 1, which means it was pressed. Mod was 0. So that means I haven't pressed any shift or control while pressing the A button. And the second time you see it is me releasing. So the action is 0, means that I'm releasing the button. And that's why you see the, like, for the S as well, I don't know what the status is, so, but if I press Shift A, then you can kind of see that, okay, so if I'm just pressing and holding Shift, then you can see the key code. The status, the action is 1 for press, 2 for hold, and 0 for release. And mod is 1 if it's shift, basically. Well, once you're releasing it, it's not a shift anymore. It's just a null key, right? So this is why this would actually work. So, oh yeah, sorry. So what's really happening? I don't know. Some reason my oh yeah, sorry. Sometimes it gets stuck if you are messing around with the console, and it would get stuck. So I'm pressing Control. It says mod 2, which is Control. I'm holding it, which is action is 2, and the same for Shift. I'm holding it, which is action for 2, mod is 1. For alt, the mod is 4, and the action is the same for all of these. So I mean, you can press, you know, all of these. If you press Control Alt, you get 6. If you press Shift Alt, you get 5. If you press all 3, you get 7. So GLFW is really, really good for input handling. And right now I'm going to go ahead and press Escape, and that's how our application closes. And I think that's pretty neat. So it's clean, it's easy to read, and it's easy to understand. So this is how you can specify anything you want here, basically. If I don't know, anything you want, really. I'm just gonna get rid of this other code because we don't really be needing to watch those. Okay, so what else can we do here? For OpenGL, obviously, what we're gonna do is to draw triangles on the screen, as many triangles as we can, and put some colors and textures and all that. And years ago, I was able to actually do this. Right now, not so much because I haven't really practiced it. But what I really want I can do is I can write some shaders and explain how they work. So as I mentioned before, OpenGL requires you to write some shaders. For example, like the fragment shader and the geometry shader and so forth. I could actually go ahead and show you guys what kind of shaders I mean on learnopengl.com. And let me actually show you getting started creating a triangle. And yep, if you navigate on this page, then you can see what the shaders actually do, at least what the vertex shader and the fragment shader does. So the vertex shader is basically acquiring some vertex data. It's a list of points, 3D points from your any kind of input, and this is what happens. You can transform your character models and your vertices and so forth in the vertex shader, and OpenGL is gonna work that out and make that into triangles. And there's something called the geometry shader, which is not very beginner stuff, so we are not gonna go, and I'm not gonna explain what that is because I haven't really worked with them. And after it has determined what the position of the vertices on the screen is, then we can go ahead and put it in the fragment shader. And fragment shader is basically coloring each and every one of your pixels on the shape, and says, okay, on this position on the screen it should be this color, and then the next position on this screen it should be this color, yada yada. And in the very last phase you would blend and do some alpha testing and all that with the colors. But it's not really important right now. So what's really important is that we need the vertex shader to specify where our triangle wants to be, and what color it should be. And I will be writing two extremely simple shaders for this, for our code. But first, what we need to do is to create files that basically specify, well, a folder actually that where we can store our shaders. So I'm going back to the project root. Sorry, Palm Engine. Yeah, I have like a lot of other stuff going on in my hard drive. So I'm gonna go ahead and type shaders. And inside shaders, it's also appeared in my Visual Studio. I can just add a new file, call it shader.anything you really want, basically, but I'm just gonna call it shader.vert. And I'm gonna say that this uses OpenGL version 3.3, which will be 3300. And is it 3300? No, it's 330, sorry. So this means 3.3, and I'm just gonna say that we are using the core OpenGL version, and we are having a... Okay, I'm not gonna explain what these are. An input or like an incoming information of a position, which is a vector 3 a position, and we have a main function very much like in C, where we say GL position is equals to vector 4 a pos and a 1.0. So I'm just gonna go ahead and pause the music. Layout and location.0, I have a faint idea what it means. That's why I'm not explaining it, because I don't know for certain. In means that this is not an output like parameter, but an incoming data. And we have an incoming data of vector 3s, and which we will name a pos. So this is our data. This is the vertices we are working with. And in this function, the main function is what basically the shader does. We have this specific variable called GL position, and this will be the one that is passed to the next phase of the pipeline, of the graphics pipeline. And the GL position should be a 4-dimensional point, which is just my vector 3 with a 1.0 attached to it. Of course, you can write apos.x and apos.y and apos.z. Z being the depth of your scene, because it's I think OpenGL is a right-handed coordinate system. That's why the Z value would be like the depth, not the height dimension. But since you don't really need to decompose your stuff like this, you can just, there is like an overloaded version of vector 4 where you can like input your 3-dimensional vector and just augment it with a 1.0 at the end. This should be 1.0 as far as I know. If it's 0.0, then that's like completely undefined point in space. In a 4-dimensional space, if you reduce everything to 0 in the 4th dimension, then it's like division by 0 on your 3D space. So this is the information we are outputting to our next phase in the pipeline, and what that would be is our fragment shader. So I'm gonna go ahead and create another file called shader.frag, and likewise in the previous file we would say the version of this is 3.3 on the core, and right now we are not expecting like a manually like a manual input from the user or from the programmer or from the CPU or whatever. We are expecting to output something. So here I'm gonna say out, I think it's a vector 4. Yeah, it is, because the color components are stored in 4 variables: red, blue, and green, and alpha. So we are outputting a vector 4 that is our frag color. And this will be the one that is being output on the screen. And for now, I'm gonna go ahead, and what our fragment shader is gonna do is basically say that this frag color is just a vector 4 of some really nice color. Like let me go ahead and see what like orange color is. Oh, right, because this is not stored as in RGBA with like floating clamped stuff, but so we would have like something like 1.0, 0.5, and 0.36 or something. So so that's 1.0 f. I usually specify this as a floating point number rather than the double. And 0.5 f and 0.34 f and 1.0 for the alpha value. So what this actually means is that your fragment color for each of your shape that you want to draw, like triangles and such, will be this color. There will be no reflection, nothing else. There you would have the color of your background and the color of whatever you are drawing on the screen. And whatever we are drawing on the screen will be this color. And obviously, this is I'm on a 4K monitor and my pixels are really dense, densely populated. We are talking about a lot of pixels. This is why this has to be executed on the graphics card. For this as well, we can have like thousands and millions of vertices going on in our scene. If you want to rotate that, you don't do it on the CPU and do it one by one. You do it on the GPU, which can execute all these transformations for the millions of triangles and vertices almost like simultaneously, every one of those. And like this is why we need to use shaders when you deal with graphics. So we are basically done with these two shaders. I'm not sure if they are correct. For now, I want to show you how to use these, which is going to be kind of complicated, but hopefully it will make sense. And I will be referring to some of my earlier code because I just need to take a look at them because I can't recall this out of memory because it's just so much information. Okay, so for now, I'm gonna go ahead and also explain to you how the 3D space is present in OpenGL. So here is your screen, and here is your view. Oh yeah, I completely forgot to set the viewport. Sorry. I'm gonna do a bit of magic here and say int width and height, and say GLFW get buffer get frame buffer size of the window, and I'm gonna store these two variables in the width and the height. And GLFW GL viewport. Sorry, I can't type. GL viewport for 0, 0 and width, oops, and height. Yeah, and this is a bit of magic. It basically I'm getting the current size of my window, which can be resized obviously. So this is something that can change, and I'm setting the viewport to be this triangle defined by 0, 0 and with height coordinates. So from this point to this point is gonna be my viewport. Everything that falls outside of the window is gonna be discarded for the calculation because obviously they cannot be seen. So we shouldn't really calculate anything for those. For optimization reasons. And for the coordinate system looks kind of like this in OpenGL. It would start the center of the screen is 0, 0. And on both x and y axis you would go up to 1.0 to from negative 1.0 to positive 1.0. So here as well 1.0. And I'm gonna define a triangle that is kind of like this on the screen. So I would have like negative 0.5, negative 0.5, and for the third dimension I would have 0.0. That's the Z. That's how deep the triangle is in the space, inside my 3D space, I mean. And for the second one, for the second vertices, I need 0.0, negative 0.5, negative 0.5, and 0.0 for the Z. And for the third vertex, I need 0. Oh, sorry, 0.0, 0.5, and 0.0. These are going to be the three vertices that we work with, and the order really matters. You should always define your vertices counterclockwise, because otherwise they would be interpreted as back-facing triangles, and we do not draw back-facing triangles. This is the correct way. The counterclockwise way is the correct way of defining a triangle that should be front-facing. It has something to do with how determinants are calculated. If the determinant of these 3 points defining a 3x3 matrix, if that's negative, then it will be discarded, and if it's positive, then it will be like a front-facing triangle. So this is what I want to do right now. So as for now, I really just need to define like an array of floating numbers. So I'm gonna go ahead and say vertices is gonna be equal to the 3 points I defined earlier, which is negative 0.5f, negative 0.5f, and 0.0f. And for the second point, it's gonna be 0.5f, 0.5f, negative 0.5f, and 0.0f. And for the third point, it's gonna be 0.5f. No, sorry, 0.0f. Sorry, I'm getting really tired actually. And 0.5f and 0.0f. Yeah, so this is our 3 points, which I was referring on this diagram in first and second and third. Right, so we have our vertices, but what we are actually going to do with them, it's still a mystery. First we need to read these files, and basically how this actually works is pretty complicated. So first of all, we need to read the shaders, and second, we need to compile the store and compile the shaders. Store and compile the shaders. Third, link the store and link the shaders. And fourth, use the program created from the shaders. Created with the shaders. Sorry. So these are the 4 steps I will be doing. It's not an easy or not a small task. So I will be defining first a function that returns a string. So we have an std, a standard string, which is read. It can be just say read file, and this receives a std string reference from, which will be like file location or something. This will be able to read any kind of files. And for safety reasons, I'm just going to go and include string. I'm also including file stream, and I also want to include string stream, so s stream. There we go. And this is going to be pretty straightforward actually. I'm defining an input file stream, standard if stream, which is going to be the file, and I'm going to say file.open file location with standard input outputs in. And if the file is not an error, or like I don't quite remember what was it. Was it bad bit or fail? Yeah, fail. If it's not a fail, then what I'm gonna do is create a string stream called contents. And if the file doesn't fail to open, then I'm gonna go ahead and contents file.buff. Hopefully this is right. I don't quite remember whether this is like this is a function. Okay, so that would be okay, and I'm returning the contents string. Right. So yeah. Okay. So I'm returning the string, the std string bits of this contents string stream. This is how I read files in C. Maybe there's some error on it. I don't really want to check right now. I want to go and progress with the how to read the how to actually compile and do all the shader stuff. So right now we need a function that reads and compiles a shader, like a shader buffer object. So shaders are like buffer objects are negate the fail check. Yes, you are completely right. Thank you. I know who you are. If the file doesn't fail, thanks. So yes, if it doesn't fail, then I'm reading the contents into the file. And so shader, like buffer objects in OpenGL, I think almost anything is stored in stored as a unsigned integer value, which we can use. We can use Glue's GLU unsigned int variable, or like a type defined stuff, like type definition to have our return type for the function that we are creating right now, which is create and compile shader, and this is gonna receive a string file location, and it will also receive a unsigned integer that is the type of shader we want to compile. So whether this would be a vertex shader or a fragment shader. I'm not sure whether that's a unsigned int. I hope it is. We will find that out later. And so what do I do now? I completely forgot. I think I need to create a GL unsigned int for the shader and say GL create buffers. Should I create? Right? I don't know. Create buffer. I think it should be a create buffer. Create shader. No, that's the create shader. And we have the shader type here. So, yep. And GL create shader is a function that returns an unsigned int, a GL unsigned int. So we can just go ahead and store that value in our shader variable. And sorry. And at this point we can basically no, we still need some kind of like GL each shader, like source or something. Shader source. Oh yeah, there it is. Shader source. Okay. What does that do? Okay, so I'm having my shader in my. What is the count? I don't know. Should that be a null pointer? Const string should be the. I completely forgot how these parameters work. So I'm pretty sure the first one is the shader that I want to put in some. I want to attach some strings to it. So I'm gonna go ahead and say, which can be a const. No, I don't want to. String as a shader source for file, and here I can specify the file location, and okay, I'm gonna go ahead and open up the suspicious looking link given to me on the chat. So shader source for GL3. It specifies the handle for the shader object, which source code is to be replaced. Yes, that's my shader. Count specifies the number of elements in the string and length arrays. Number of elements in the string and length array, so that should be like 1, I guess. String specifies an array of pointers to string containing the source code to be loaded into the shader, so that would be my shader source. Shader source dot cSDR, which is my wait, what? Oh, I see. Okay. You won't fool me, C++. Just sharp pointer. Shader or something, I don't know what to call this. Shader source dot c string, and for this I'm gonna using cShader, and still not good enough. I don't know what's wrong with this. Const character pointer is incompatible with const GL car const. Sure, that's it. I remember making this work. Let me check my other source. My other source, which would be this, I think. It's not. This project is a lot better, but some a lot of things going on. So I have my create and compile shader with file location shader type, and I'm reading in my file that is okay like that, and then I'm storing it. Interesting. This should be good. This should be good. And then I have my shader defined. That is good. Shader, oh yeah, this should be a reference. Or pointer, sorry. Like the memory location. And for the last parameter, I believe, if the documentation is right, length specifies an array of string lengths. I don't know. Doesn't really tell me what to do with that information. So anyways, we now have our shader, and inside that shader we have our string which we have read from our file. So we are reading the file, we are putting that inside the shader, and what we should do now is compiling the shader. And how we do that is just basically specifying which shader we want to compile. And after this we can do some error checking, because debugging is pretty hard on shaders. So like we can go ahead and store, like create a variable where we can store our success status of our compilation. So we can get gl get shader iv. I don't know what iv stands for. Whether that's a for or iv, I don't know. So we are getting the status of shader with we are storing that in, oh sorry, we want to get to know the compile status. Yep. And we are storing this information into success. And if this success is not it's not true, or not like a positive number, if it's 0, that means something failed. So we can specify a character array of, I don't know, info log, which is about 512 characters long. Inflog, that should be info-log. And I can get the info-log with gl get shader info-log. And again, I'm getting the information from the shader. The buffer size is 512, not 521, but 512. The length is, I don't know, the same as before. It's null pointer. And I'm getting the info log memory address. And after that, we can just go ahead and output that shader error with the contents of info log. And maybe, oh yeah, if this doesn't run, or like if everything is okay, then we can just return the shader, which is like gonna be a number stored on the video card anyways. So with this code, like we pretty much can handle like compiling, creating and compiling our vertex and fragment shaders. What we need is actually to create something that like we need to create a program, a shader program from these two shaders, and that's gonna be an unsigned int as well. Oh, iv is int value. Okay, thanks. Might be vector as potentially getting multiple values. Okay. Maybe. I don't know. So right now we need to create a program from these shaders, and not only create them, but to link these, like to link the program, which is like kind of like compiling and linking program in like normally how normally do it, but this is in the shader world. So I don't really remember how to do this. Create and link program. For this, I'm gonna use a I think this, I don't need any parameters for now. For now, but I can create my two shaders. So unsigned GL unsigned integer, Vertex shader is gonna be create and compile shader. Oops, create and compile shader with the file location. I'm gonna specify this later. And for the shader type, this is gonna be GL Vertex shader. And for the other one as well, GL unsigned integer, fragment shader is the same as create and compile shader with some file location and GL fragment shader. Okay, so this looks good. Now the question is where the file location comes from. And as I said before, we are using CMake to build this entire project, and your build location would be different every time you use some different IDE. What you can use is somewhere here down off, I think, off the stream, because like this is not the bottom of my screen, but only the bottom of the space I'm sharing. I can say change CMake settings, and I can go ahead and say for the 64-bit debug version, I want to change the build location. So the building root should be project dir, and I think that's perfectly fine for now. Let me see if everything is okay. And I don't think everything is fine, because no, actually it is, because we have created our build folder. That's good. However, this yellow notification thing hasn't really disappeared, so I'm kind of concerned. Sometimes Visual Studio gets stuck on this step, so kind of concerned whether this would work. But anyways, so now our project or executable would be stored inside build. Let me actually open up in the file explorer. So our executable for this entire project would be stored in build, x64 debug, and inside that Palm engine. And here we would have our exe as well. So if I were to build my files again, so my glue libraries and my GLFW library and my Palm, this wouldn't compile, right? Because I haven't specified any input locations. For now, let's just gonna put in some empty strings so it compiles. So okay, so build failed. I messed something up. Create and program link must return a value. Okay, so I messed up that part. Oh, of course, I haven't finished with this. Okay, so return one. I don't know. What I want to show right now is, okay, so build succeeded, is that if I go back to the file explorer, is that in this build we do have our executable right there. And if I open this, then there's my program for me. And from this location, we need to find these shader files. So that's gonna be 1, 2, 3 folders up, and onto the shaders and onto the file themselves. So this would be 3 folders up, onto the shaders folder, and Inside that we have shader.vert, and we have the same, almost the same parameter for the fragment shader, but instead of vertex we need the fragment shader. So I'm pretty keen on actually checking these, so I'm gonna go ahead and debug these codes. I'm just gonna go ahead and call this somewhere here. Create and compile and link program. I don't think no, yeah. Okay, so I'm calling this method, and I just really want to check whether I'm actually reading out the shaders themselves. So I'm just gonna go ahead and compile this one more time. So build is succeeded, and of course I need to select the valid program. Okay, so right now we are here. I'm just gonna go ahead and debug inside there. So we have the shader source, and it seems that if I add this to the watch, shader source to the watch, then you can actually see that, wow, you can actually see that here is the contents of our file. So I think this works pretty well. It's gonna go ahead and break here as well. Yeah, I know. Okay, I think I skipped it. So anyways, yep. And that looks like my fragment shader, so everything is good. Just gonna go ahead and run it and close everything. So okay, so these locations are good. What we need now is to create a OpenGL program, which is gonna be another unsigned integer. Uint program is GL create program, which doesn't take any parameters, thankfully. And I think I need GL attach shader to my program, and I'm gonna attach the vertex shader first, the vertex shader, and GL attach shader to the program, my fragment shader, and now I can go ahead and say GL compile, link program, sorry, link program, and I'm linking my program. And of course I can refactor, or like take this error handling stuff and almost copy paste it here. But for linking program, it just gets like different parameters, but the idea is the same, is that you would have like a success flag of some sorts, and you would get the status of your program. So GL get program IV integer value, as it was mentioned to me a few moments earlier, and I want to get the status of my program, the enum type of GL link status, and I want to store that in the success variable, of course, because I misspelled success there. So again, if success is 0, so if it's not succeeded, then I can create a info log of the same 512 bytes or character sizes, container stuff, and go ahead and say GL get program info log for my program, and the buffer size is gonna be 512 bytes, like size of characters times 512. Length is null pointer for now, and I still have no idea what it means. And I'm gonna store this info in the info log, which is a string. And after that, I'm gonna go and output the error on the screen. So that's program, maybe GL program link error, and output the info log as well. This is some error handling. Otherwise, I'm gonna return the program. If I could type program. So this looks good. See, this part is almost like everything is almost the same for both the shader and the program. It's pretty simple. It's pretty unified in a way. And now this is a part where I think I was able to do this 2 years ago or maybe 3 years ago. Now I'm completely I completely forgot how to actually create these buffers, like vertex array buffers and vertex VBOs and VAOs, vertex array buffers and vertex something else buffers, and how to actually use them. So I'm gonna go ahead and cheat and look at my earlier code, which I actually took from well, I practiced before, but I haven't memorized it yet. So with this program, I can store this program. Okay, let me close a few things. Okay, so right, so I need an unsigned int of the shader program, which is gonna be this that I already defined earlier. And now I need to set some buffers which would bind the information to my video card, and set what sort of like what kind of in what ways I want to draw my stuff out on the screen. I should have practiced any of this, but I haven't. So right now I need a vertex buffer object and a vertex array object, which would do these bindings to my video card eventually, which are going to be unsigned ints. So that's going to be GL unsigned int again. No, not uniform. GL unsigned int. VAO, VBO, and VAO. It doesn't matter which way. Just vertex buffer object is a bit. It's inside vertex array object, as I understand correctly. So that's why I define VBO first and VAO second. It doesn't matter at all. And I'm gonna generate a vertex array object, the size of 1, and I'm gonna generate that on VAO. And I'm gonna generate buffers then. GL gen buffers. Also 1 on the address of VBO. Oops. And now I'm gonna bind my vertex array. So GL bind vertex array. I have no idea how any of this works on the pipeline and what it does in the video card. I just know it's needed. Sorry, I don't work on this. I don't know anything about video card management and graphics, because it's just a hobby of mine. So I haven't really dug into the theory part of this, and whatever I did in the university I already forgot. So now I'm gonna need to bind the buffers of the VAO object. So that's gonna be a GL. This takes two parameters. First one is the kind of like the type of buffer we want to bind, which is gonna be a an array buffer, and what we want to bind is the VAO. And in the next line is, or the next command for the GL is gonna be the GL buffer data. This is the line. This is the most important line, I would say, which kind of defines how our data looks like, or how our data should be interpreted in terms of what the vertices are. So this is a GL array buffer, and so we are basically saying what this is, this vertex array, what that is, how that should be interpreted. So we want to interpret it as size of in terms of vertices, with each vertex taking up the 3 times the size of a floating number, because each component is it's a floating number in our vertex vector whatever definition. There's just 3 float numbers, and this is why we multiply by 3, because each of these vectors are like components are like 3 times the size of a float. And I have no idea what the fuck this is. It just is. It's very similar to a callback function casting, some kind of very old C way. So I'm getting some syntax errors because I completely... Oh fuck, this is not the stuff I wanted to write here. Okay, so our data is inside the GL array buffer has the size of vertices. It starts from the memory address of the vertices, and how we want to draw stuff is just statically draw everything. This kind of indicates that we are not changing the data inside this vertex array, which allows the OpenGL to optimize and put this array onto a a memory location where it's it's faster to read stuff. So this is why we specify the static draw. This could be dynamic draw or some other stuff. Dynamic draw means it would change frequently, but we are not doing any of that. So what I was typing was actually now the most important line is how our vertices array should be interpreted, which is GL vertex attribute pointer, which takes some numbers. Obviously, we are starting from the 0th element in 3 components. Each component is a float. Normalized, I don't know what this actually means. It's explained on learnopengl.com, but I don't think it's really important. I think it's since every one of these coordinates should be inside clip space, which is the space which goes from -1 to 1 inclusive. So if this is not normalized, then OpenGL needs to take some steps to normalize it. But this is not needed currently, so because we are inside clip space. So I'm just gonna say, okay, it's not face but false. It's not needed to normalize our data. and the stride is 3 times the size of float. So this is how much space is between every vertex point. And this I have still no idea what the fuck it is. So it's just a void pointer to 0. And I don't even want to understand it. This is so C, so legacy code that it doesn't look good and it's hard to read. And fuck all that. So no. Okay, so next I want to, for some reason I want to disable these buffers. So enable vertex array buffer would mean, sorry, enable vertex attrib array. Attrib array is that I'm enabling this on the 0th location. And GL bind buffer. This is what I kind of don't understand why I need to. Oh yeah, this is just me. Offset pointer. Oh, okay. It's easy to understand, offset pointer. So after I have my buffer loaded and like everything attached to my attrib pointer, I can like disable, quote unquote disable, or turn off my buffer objects. So I can like unbind my buffer stuff. So my array buffer, I want to bind it to 0, which is like disabling it. GL bind vertex array would be 0. I have no idea what any of this means. And I'm too tired to understand any of it. So we are basically, this is like the main part of how things are gonna be, like how the shaders are gonna do their work inside our render loop. So in the render loop, I can just go ahead and say, before we swap buffers, I can just go ahead and say GL use program. So I'm gonna use the what? Oh yeah, it's called shader program. Shader program. I'm gonna use the shader program to apply everything on the scene. Apply it to everything on the scene. I'm gonna bind my vertex array. GL bind vertex array as to my VAO. I'm gonna bind my VAO to, so it is used. And now I'm gonna go ahead and draw my arrays, which are filled up with my 3 vertices. I'm gonna go ahead with draw them with GL triangles, and first is gonna be at 0, and 3 is again it's just how many vertices I'm drawing from this vertex array. So so this is basically it. Before I quit the application, I'm also gonna delete some stuff. So GL delete vertex arrays. I'm gonna delete 1, and I'm gonna delete my VAO. Also gonna delete the buffers. So GL delete buffers. Also gonna delete 1, and I'm gonna delete the VPO as well. And after that, I'm just gonna go and delete the program, which is my shader program. Shader program. To be clearer, you could unbind the VAO and unuse the program. Won't matter now, but still, yeah. I guess. Okay. So anyways, we have something to work with now. I can just go ahead and build that again. Hopefully this is succeeded. Perfect. And let's go ahead and start it and let's see what it does. Okay, so magic time. Here's my command prompt, which is empty, which is really good for now. And here's the window with our triangle. And of course the clear color is the same old pink I used a few hours ago. And as you can see, on top of the background color, the clear color, I have my orangish shader color, which is red from, which is orange, but which is red, so red out from this fragment shader. So I can make this very disgusting blue, like some very off-putting colors. So if I change the fragment color as such and run my program, then you would see this. And I guess this is perfectly fine to demonstrate how you can use CMake and GLFW and the glue to create like to create a very well managed OpenGL application. And this is basically was the point of like me trying to spike my way throughout these routes of how I can make this happen. Now, unfortunately, CMake is really flexible in its way of how you can like set stuff in it. So there's like literally everybody is doing it differently. It's really hard for me. It was really hard for me to actually get some sensible and helpful information online because everybody's using it differently and it's super chaotic, I think. But this is why I kind of like wanted to show this stream to explain that it's not impossible. You just need a lot of research on it, and it's certainly possible. So that's pretty good. Now, of course, I don't need to recompile any of my program if I'm changing shaders because the shaders are read from a file, so they are resource bound. So I can just go ahead and change my fragment, like my shaders, without having to compile my program. So yeah, this is basically it. Let me show you what happens if something is messed up in the shader. So I know I now deleted an O from the variable name. If I start this application, then we would get a shader error. Says undefined variable flag color, and this is why I did those error handling stuff, because this is kind of helpful for me, where to look for the error and what the error could be. If you don't, obviously the program is still gonna run, but the shader is just gonna be completely inactive. So this is why you see like a black color on the triangle. And now, of course, this is some pretty basic stuff, like extremely basic, below any kind of like expectations. This is like so below expectations that I would need to define my projection matrices in order for this triangle to be displayed correctly. Because if you see, if you notice that if I'm dragging this window, the triangle is going to be like super skewed, and that's not how 3D space works. It should still be like a normal triangle somewhere in the middle of the screen. Something like this. The shape should be like this, but the kind of the width and the height define my like my project space, like it distorts the space as well, and this is why I would need to kind of introduce new like a projective matrix, like a mat4 projection matrix that would do something in my that would do like that would transform my position to the of my vertices to their correct places, and then my triangle would be displayed correctly no matter how I play around with the window size. So I think this is where I'm gonna end up. My throat really hurts, and I'm getting like really super tired. But I just wanted to show that this is kind of okay to do in CMake. It's not a very hard thing in my opinion, but this is something that you can build upon. And I really hated the times when like I didn't really understand any of what I'm doing inside the with OpenGL, and what shaders do and how are they being read and so on and so on. And like in university, what you would basically do is get like a project from someone which was written for you, and you would change a few numbers there, and you can play around with the values, but you wouldn't really understand how that worked. And of course, with the Visual Studio settings were like completely crazy. So like right click and go to like properties and set this up and set that up, and I just didn't understand why I cannot do it in like a lot more easier way. Well, I mean easier as in easier to understand and easier to follow, and a lot more generic way. And this is why I started to kind of research how I can use CMake in order to do anything I did in university years ago. So I think my voice completely turned to gay dragon. I don't know how else to describe it, but it really hurts. So I'm gonna go and stop with the stream. I really thank you for the help. I know who you are, and thank you so much for the help. I think it would have taken me like 3 hours to recognize that I messed up the file reading, and thank you for explaining some stuff with regarding the OpenGL commands, because I do want to understand them. And well, I just don't have the capacity to spend a lot of time with OpenGL. So again, thank you so much for tuning in, and I might continue with this kind of stream maybe in I don't know, whenever I have time to progress and kind of share what I've learned in like a more structured manner, because right now you can hear it on my voice. I haven't practiced any of this. I was just starting to I just started to stream and then started talking whatever came to my mind. Um, so anyways, thank you for watching. I will be putting this up on YouTube, so I can so whoever wants to can like watch this back. I might copy the chat into the description. Might not. I'm not sure. So because the chat, I don't think the chat shows on the screen. I have everything deleted in my OBS sources, so there's no way the chat was shown there. So anyway, for the fifth time, thank you for the fifth time. Thank you so much for watching, and I hope to see you guys sometime, whenever in the future. Bye bye.